So back with the Need to Know Schlegel Notes Part 3, and I'm also going to do the Schlegel experiment intro in this video, so when you receive this, it will not have a video link here, or down here. It will just have a video link. I'll put it down here instead of up here. But anyway, as we go through today, we're going to be talking about some different things, one of them being compound interest, which we did in Chapter 5, and this is a formula for compound interest. So what we're going to be wanting to do with these things eventually, and I'll have separate videos on how to do this, we're actually going to want to create an account in Wolfram, and we're going to want to save these formulas in Wolfram so we don't have to type them every single time. So for instance, there's compound interest, and you can see like continuous compounding is here also. And if we continue down, these are two things that you haven't come across yet. These are unique to Chapter 6. So compound interest and continuous compounding are both things where the value is increasing, and they are both occurring when there is a lump sum put in. So what I mean by a lump sum is there was some money put in, and then no further contributions were made. So that's an example. We've had lots of examples of that in Chapter 5. What separates compound interest or continuous compounding from an annuity is that an annuity is characterized by having regular monthly payments. And so like every month I make a car payment. That behaves like an annuity. Every month I put money into a retirement account. That behaves like an annuity because I have regularly scheduled recurring payments. So again, up here, no recurring payments. And down here, scheduled regular recurring payments. And so future value of an annuity is going to be this nasty looking equation right here. And don't freak out. We will learn more about these slowly, but I will be using this today. That is for when the value is increasing, so you're putting money into the fund. Present value of an annuity is different. The value is decreasing, and that's when you are withdrawing money from the fund or making payments to pay it down. So like my car payment is an example of this because I'm decreasing the value of the loan over time. When I retire and I take money out of my account, this will also be an example of that because I will be taking money out of the account. So my retirement right now behaves like a future value of annuity because I'm putting money in and that value is increasing. When I retire, my retirement account will behave like a present value of annuity. The value will be decreasing because I'll be taking out regularly scheduled payments. Then over here on the side, we have a bunch of variables. And so I need to let you know that on each one of these, you'll see S on the left. And for whatever reason, they choose to use a capital S as the future value of the investment. And so that's how much money it's going to be worth after a period of time. R is going to be the lump sum in the account or the recurring payment. And so here for the compound interest and the continuous compounding, if I put $10,000 in the account, that would go in where R is at. And down here for the annuities, remember annuities are regularly scheduled recurring payments. And so for me personally, there's about $900 a month that goes into my retirement account. And so that would go right here. That's the payment going in. I'm paying off a Jeep right now, and so I'm paying about $600 a month on that. That's what would go right here because the value again is decreasing of the remainder of the loan. So R is the lump sum for these or the continuous payment either into or out of the account for these two. Lowercase r is going to be the rate in interest, so that's going to be the percent. M is the number of compounding periods, meaning that if an investment is compounded yearly, this would be 1. If it is compounded semi-annually, this would be 2. If it was compounded quarterly, this would be 4. And if it was compounded monthly, this would be 12. And so in each one of the problems, it's going to explicitly state what the compounding periods are, and we just have to pay attention to that number. Lowercase t is always going to be time in years. And in order to make these formulas simpler, yes, I said simpler, which seems like this is super complicated already, we actually use I and N as variables in them. And I is going to be R divided by M. And so you won't see R or M in any of these. It's because, again, to make these formulas simpler, we just turn these two numbers into one. So we only have one thing to type in where we see the I, and then n is going to be equal to m times t. And so we're going to go through a process of filling out as much information as we have when we do these problems, figuring out what I and n are, and then plugging those numbers in and letting Wolfram do some work for us. So initially I said that I was going to do both of these in one video. I think that would be too long, so I'm going to cut it off now, and I'll be back for a video on the Schlegel experiment.